Hello friends, today we are going to study about pulse width modulation. So what is pulse width modulation basically? Pulse width modulation is nothing but a technique to provide optimum power to the any electronic circuit. Power is equal to voltage into current. So for example, if any battery is there, battery has 12 volt and 5 amperes, the total capacity or the total power rating of that battery will be 12 into 5. It means 60 watts. So this 60 watts capacity will be actually possible with this one, with that battery. So what we are going to do here is this 50% duty cycle means this is a complete cycle, you can say. This will be cycle number 1. This is one complete cycle. Same way, this is another complete cycle. Then this is another cycle. So you can see that this distance will be always equal. This distance will always be constant. This is called total time. This is total time. So for every cycle to complete, this will be the total time available. And in that total time, you can see that 50% it's remaining on and 50% it's remaining off. So how much time it's remaining on? It's remaining on for half second, for example, and half second it's remaining off. So the total duty cycle will be, as per the formula, total on by total time. So for example, so how much will be the duty cycle? It will be 0.5 divided by 1, because half second divided by 1 second multiplied by 100. So 50% duty cycle. Same way, if you can calculate here, that is 75%, 25%. So totally it will be like 25%, 75% duty cycle and 25% duty cycle. So how much time it's getting, duty cycle is getting on, that much maximum power can be achieved. So you can say that this will provide 25% of the overall power available in that circuit, and this will provide little more, like for example 50%. So 25% duty cycle basically means that it will provide the 25% of power only to the circuit. 50% means it will provide only 50% of the total power available in the circuit to the load, and this will provide 75% of the total available power to the load. It means that more is the duty cycle, the more amount of power you can give to the load. That is the basic things. So what is the definition? Definition is, it is a technique that is used in electronic and electrical circuit to control the amount of power delivered to the load. So that only I told you before, that how much amount total power is available. So out of total power, how much amount you want to give to the load, that you can decide using duty cycle. Maximum you can give means you have to give 100% duty cycle. It will be continuously on. You have to give 50% means you should give the duty cycle as 50%. So what is the calculation? Calculation formula is same. Total on time divided by total time multiplied by 100 is the formula for duty cycle. What is the application? If you want to rotate the motor into maximum speed, so what you will do? You'll give 100% duty cycle. If you want to rotate the motor with the half speed, you'll give 50% of the power. So that will be like 50% duty cycle. Dimming LEDs, like for example, if you're giving more power to LED, it will glow more. If you are giving less power to LED, it will glow less. Then to generate analog signal from digital sources. So from some digital sources, you want to control that voltage or control current of that electronic circuit, that also you can do from this one. So what is the advantage? There are many advantages. The main advantage is like you don't need to use any additional electronic components to regulate the power. From the microcontroller itself, it's possible to control the power of the loads. And it will not produce too much heat, because generally what happens now, if you are using any external regulators and other ways to control the voltage and current, it will additionally dissipate some amount of heat. So those things you can rectify using PWM. So example is our motor control and LED dimming circuit. So in your homes also you can see that light dimming circuits are there, or that motor speed control circuits are there. There PWM is widely used. So let's see, let's go to the practical and we'll see that what all the things are there. So let's have a look at the practical PWM circuit. So what we are going to do, we are going to take one Arduino as usual. And you know that many students were thinking that this is minus, but this is not minus, this is wave. And this wave represents PWM pins. So we can take pin number 3, 5, 6, 9, 10, 12, 11 in any Arduino UNO where these PWM pins will actually work. So for that, to demonstrate PWM, we need to have, we'll take something like, we'll take one LED. And you know that if we are taking LED, we should also take one resistor, because this Arduino can provide a maximum 5 volt and this LED runs from 1.5 volt to 3 volt. So that ratings we have to adjust. So you know that pin number 9, we are going to take this one here. We'll take one resistor and we'll connect in pin number 9. So now this connection is done. So you remember that this is positive connection, so we'll give it to a red color. And this is ground, so that ground will connect into this. Now you remember I told you in previous classes that if you are taking, if you are connecting LED with 5 volt supply, means your resistor rating should be 220 ohm. So try to take it in ohm only, otherwise it won't glow properly. Now the program for PWM. So a program for PWM is pretty simple. It's not very tough. It's easy one. So you can take any pin I told you, no, pin number 9 or any PWM pin you can take. So I have taken pin number 9. So we have to declare what is the name of the pin. LED pin is the name of LED pin. I have given the name of pin number 9. You can declare anything. You can just give int also. That's fine. So now in void setup, you know that this part of the code will run only once, and it is for initialization and all. So LED pin is the output pin. You know that because LED is connected, so LED is always the output. So because it's an output device. So then we have to have a serial begin, because we want to see the output here in serial monitor. Means we should you must declare serial begin at first. Now this is a loop program. Loop program runs continuously. So this part of the code is very simple. You understand, I think. So this is the value will start from 0 to 255. Means the PWM value actually you can give from 0 to 255. 255 being the maximum and 0 being the minimum that we are giving in the range. And we are telling that initially uh, it should increment this dim value. Dim value is nothing but the PWM value. So it should increase 5. Like it should start, the LED should start from 0, then add 5 PWM, then add 5, then add 5, then add 5, then add 5, like from 0, 5, 10, 15, 20, 25, 30, 35 till 255 it should go. It means the LED will start to glow higher, because PWM is increasing with the 5555 rating till 255. Once and it should be, you remember I told you before we have written digital write. So digital write and analog write has some difference. Digital write means you can give only on or off, but in analog write you can vary the values. So that is like you want to give maximum voltage, less voltage or lower voltage, so that you can adjust. So that is here. So here if you are giving 30, it will glow less. If you are giving 50, it will give little more. If you are giving 100, it will go a little higher. If you are giving 200, so you can adjust actually. So that's why this is analog write. And we have to print the value. What value is at present running, that we can see. So that also you can see it here. So that is your this one. Then 30 millisecond delay. That is a rule that you should give some delay. Then the circuit will be stable. And for every 30 milliseconds, the same thing will be repeated. So once it reaches 255, then from 255 what will happen? From 255 it will go to 0, but with the decrement of 5. This is increment of 5, this is decrement of 5. And the same thing happen. It will write the effect to the LED. And it will also display the values in the serial monitor. Now let's see the circuit. So if I start the simulation, you see what happens. See, this is glowing high, then low, then high, then low, then high. Now we want to see what's happening here. So we go to serial monitor. So in the serial monitor, you can see the value is keep on increasing, right? See the value. It's keep on increasing till 255 and then it decreases, right? So 0 to 255, then again goes to 0 as per the program. So we want to see the visual effect of this one. So what we'll do, we'll add one oscilloscope there. So oscilloscope, we have to take it from the circuit. So we'll write here oscilloscope. So this is oscilloscope. Oscilloscope, you can take it from here, and you have to add this is very simple. You can see that here is a positive terminal represented by a red color. So that you have to take it and add it in before resistor because we want to see the actual PWM and change this to a red color. If it is not connecting properly, you can connect in any ground wherever you want. And we'll give this as a black color. Now we want to see the outputs. So start the simulation and see. You can see that how it is happening. It's going to the maximum dense and minimum dense, means 100% duty cycle and 0% duty cycle. So this was the experiment 1 where you are learning how to generate PWM and how you can control the brightness of LED based on PWM. So for experiment number 2, we are going to connect one motor with the same circuit and we'll see. LED already you know, we'll connect one motor also. So this is one motor, we'll connect it here. And this time we'll give positive to pin number 6. Pin number 6. And we'll make it red color. And we'll give this ground. You can give ground from any of the 3 grounds available. We'll change the color to black. And now we are going to write the program. So in the program, what I have done, I have not done anything extra. Just the same thing. I have declared one motor pin number 6, and we have given motor as output. And the same thing, I have added motor also, that whatever will happen to LED pin, that same thing will happen to motor pin also. And the same thing will happen when the decrement is happening. And we'll try to run the code and see the output. You can see that. I hope you are able to see the RPM values. RPM is revolution per minute. So you can see the same thing is happening here and same thing is happening here also. The dense field represents the maximum duty cycle is consumed and the narrower field means that is lower values there. So you can see simultaneously you will find that one thing, when that dense field is coming, means the 100% duty cycle is coming, that time the speed is maximum. And when the minimum value is coming, that scattered plots are coming, that time you will see that the value of RPM is very less. So this was experiment number 2. I hope it's clear. This is our experiment number 3 where we are going to learn about button debounce. So button debounce and PWM we are going to combine. So what is a button debounce? You can see that in previous circuits we are giving the command and it's increasing and decreasing the PWM. There is no control of ours on those PWM values. So here we want to give a control. Control means when I press this button, it should increase the speed a little bit. When I want to, if I'm pressing this button, this will actually reduce the PWM value to a little bit. Like you can control basically the speed of motor or LED or whatever device you connect here. You can control their PWM values. You can increase their speed, decrease their speed, increase their brightness, decrease their brightness all at a time. So that circuit is here. Circuit is not very tough. You can see that I have connected one resistor here, that is 10 kilo ohm resistor, 10 kilo ohm resistor here as well. So you have to give one positive, one negative, one positive, one negative to the 2 buttons. The buttons you can get it from here. You can just type here button and you will come. It will come here. From push button you can take from here. So that's up to you. So these 2 buttons you declared positive, negative, and you can give 3.3 volt. Don't give 5 volt here. We have given 3.3 volt. Even 5 volt is possible, but in that case you have to increase the resistance value. So we have given 3.3 voltage here. Now output always you should take from ground side. Like you should not take from positive side. It won't work. You should take it from ground side in both the cases. Now you give it to pin number 2 and pin number 4. So you can identify here whatever values are coming here, that will be detected. Because we are not using PWM pin here, we are using digital pin here. Means we want to know that whether it's on or off or on and off for how much time. That only basically we want to find. Then pin number 5 is the PWM pin that we have used to control the motor. It's your wish, you can use any pin, PWM pin, that's up to you. And ground side we have connected to the ground of this, and this is oscilloscope to see the output. Now we have to write the code. So in the code also it's not very tough. You'll be able to understand it. I'll explain you right now. So we have given pin number 2 and pin number 4. These two are digital pins. So that digital pin we have used for one. The name of pin number 2 is up button, and the name of pin number 4 is down button. So this to increase the PWM and this to decrease the PWM. And where the PWM is actually happening? PWM is actually happening at pin number 5. So PWM initial duty is 0. We are declaring that the initial is 0. Up button state, down button state, like you have to declare that what is the state of the button. It is an on condition or off condition. So some name should be given to that one. So initially we are considering that button state is always low, means when the circuit is started, that time the button state is low. Now unsigned long last up debounce time is equal to 0, last down debounce time equal to 0, debounce delay equal to 5. Like do you remember that we have already declared that debounce delay will be 5. Like there should be some like we have to give the range, like within the range only it should work. So debounce delay 5 you are giving means if you are pressing the button for 5 milliseconds, then only it's considered 1. If you are pressing less than that, it won't be considered as a button. If you are pressing, so that 5 milliseconds means here you are giving the time. Okay, so for this much time only the button is pressed, so it's counted as 1. I mean, one button count is given. That is that time delay you have to give it here. If you are giving it 1000 millisecond, what will happen? At least for 1000 millisecond, you have to keep pressing the button. Then only it will be counted as 1. So that you can just change and see that what all the effects are coming. Now, void setup. Here, up button is, you know that what button is input, what button is output. In the circuit itself, it's clear. So you remember that up button means we are giving the command. So that is input pin. Down button also we are giving the command, so that is the input pin, and PWM pins are always the output pins. You should understand if you are using that to drive any circuit, then it's always the output pin. PWM initial duty is 0, and this is you already know that serial begin is used to see that output in serial monitor. Analog write is PWM pin, PWM duty. So based on whatever is the PWM duty is coming, I mean what all the values are coming by pressing the button, that it has to write. So that only PWM pin will be written with the PWM duty. This is the loop program. Initially, you can see that digital read is up button pin and digital read down button pins. Means these two are actually checking that which button I have to read, right? Whether I have to read the up button or down button, both it has to read. So that one we are declaring. Now up reading and last button state, that it has to check. So if the last button state and up button reading is actually available or not available, then it has to calculate the in milliseconds. So how much millisecond that button was pressed, and this is called debounce time. Debounce time means if you are pressing any button and for how long it's pressed, that detection, and based on that it has to take some action, that is called as debounce. And the time declaration for how many seconds it should be detected, that is called as debounce time. In my case, in our case, that is 5 milliseconds. So it is checking here whether the up button is pressed and down button is pressed and the condition of 5 millisecond is fulfilled or not. So that it's checking. If it is finding that debounce time, if it is crossed 5 millisecond debounce time, like if you're pressing and leaving before 5 millisecond, which is actually not possible, I think, because 5 millisecond is 0.05 seconds. So if you are giving for 30 seconds, 40 seconds, then okay. But 30 millisecond also you are giving means you can press it and come. So it won't count. But here it is, if once it crosses 5 millisecond, it will be counted as okay, 1. So once it is detected that okay, one time the button is pressed, what it will do? It will just increase the PWM value, PWM duty value to 1. It is if every time you're pressing, it will be 1. I mean, for example, the PWM value was 100, it will become 101, 102, 103, 104. Like that, it will be keep on increasing. And the same thing is happening with the same code is actually here for down. If it is finding that that button is pressed, it will start decreasing with 1. Exactly the same thing which was happening in the previous program, but here we have controlled it with the button. Now serial print. So here why we are writing this one, to just know that what is the PWM cycle right now going on, and the same thing it should be written to the a motor, like it should, the same effect should happen to the motor. And if it will just read that last button state and up button state for the next further readings. So with this, we'll see this demonstration and see how it's going to work. Okay, so just I'll try to make it as big as possible and start the simulation. So you see that whenever I press up, the RPM value actually increases. Can you see? It's 21. I mean, some amount of voltage is coming here. 21 is coming, 21, 22 is coming. Now see, if I press this button once again, what will happen? This is now 45, 44, 45, 46. So that value. And the same time, this also increased. Now we'll once again press it. I will press this 4, 5, 6 times. So now you see that it became 84 to 90. That, and the same time, this value is also, this becomes thicker like that. Okay, and if you want, you can see this in serial monitor also. We'll go to code and we'll go to serial monitor and we'll go to serial plotter. So serial plotter will basically plot these things to show you the results. So if I increase this, you can see that every time I press, there is a spike because it's increasing. How many times I keep on pressing? You can see the PWM value and the corresponding serial plotter value. Like I can keep on increasing. I can keep on increasing till 255. It will be increased. At the same time, if I am pressing this, it will be keep on dropping. Keep on pressing. Like can see that once it is pressed, it's going to the value. If I'm pressing this one, the value is keep on increasing. Yes. And at the same time, the speed of the motor will be controlled based on that. So that is the overall system. And if you leave it, it will not work. I mean, it will be running with the same speed. So this is the basic process to control the speed of motor, and LEDs and button debounce is just to identify that for how much time the button is pressed, and based on that, new action is performed. So your take-home assignment is you have to create a simple countdown timer based on that adjustable knob. That adjustable knob is nothing but this type of potentiometer. So this type of potentiometer that you can also use to control this LED and all. So this we have not to do, but just you have to see that from here also you can control this LED PWM. So the same type of potentiometer you have to use, and you have to make a countdown timer. With increasing this, the time of the countdown should increase. With decreasing this, the countdown of the timer should decrease. And if you leave it, it will start as per the current countdown. Thank you.